Hi everybody. So in this video, we're going to look at modeling with projectile motion, and we're going to focus on creating the formula between the vertical displacement and the horizontal displacement. Okay, so in example 1, we've been told that a particle is projected with a speed of 7 meters per second at an angle of elevation 30 degrees from a point O and moves freely under gravity. The horizontal and vertical upwards displacement of a particle from O at any subsequent time at t are x meters and y meters respectively. And then for part A, we've been asked to express x and y in terms of t and show we can create this equation. And for part B, we're going to use this equation to find the x value when y is 0.6. Okay, so clearly there's a lot going on here. So the first thing I'm going to do is I'm going to start by sketching a graph. And the idea is to put all the information from this description into this graph so it becomes a little bit more simple. So we're told that the particle is projected with a speed of 7 meters per second. So we know it's going to look like a parabola. And the initial speed will be here, and we'll say this is 7 meters per second. Then we're told it is at an angle of elevation of 30 degrees. So we'll mark this angle here, 30 degrees. And it moves freely under gravity, so we'll include gravity acting vertically downwards. I just need to move this across a little bit. So we know this initial velocity of 7 meters per second will have a vertical and a horizontal component. We'll call the vertical component going vertically upwards u, y, and because this doesn't contain the angle, this will be 7 sine of the angle 30. The horizontal component of velocity we'll call ux, and because this does contain the angle, this will be 7 cos 30. So now if we look at resolving the motion vertically upwards, so resolving upwards, using our CVAT, we know displacement is given as y, which is given here. The initial velocity we've just worked out as 7 sine 30. We know the acceleration is negative g, and the time we don't know, but we'll call this capital T. And because we're trying to come up with an equation involving y, we'll use s is equal to ut plus a half at squared. We'll substitute in our values, so y will equal u, 7 sine 30 times t, so we'll say 7t sine 30, plus a half a, which is a half of negative g, so we'll say minus 1/2 g, and then t squared. So now we've got an equation involving y, we're going to come up with a similar equation involving the horizontal displacement. So if we resolve horizontally to the right, we know the displacement now is x, the initial velocity is 7 cos 30, the acceleration is 0, and the time is, again, capital T. So using the same formula, x will be equal to u times t, so 7t cos 30, and for a plus half at squared, the acceleration is 0, so that bit will go. So what we want to do now is to work out this value of t and then substitute this t into our equation here. We're going to substitute it into here because we want to make y the subject. So t will equal x over 7 cos 30. And we'll call this equation 1. And we'll call this one equation 2. So now we're going to substitute 1 into 2. So if we start with this y, this will equal 7t, and we know t is x over 7 cos 30, sine 30, minus, we can work out 1/2 of g, and then for t squared, well, I'm going to square this, so we get x squared over 49 cos squared 30. So now we can tidy this up. We can see this 7 will cancel with this 7, and the sine divided by the cos will give us tan. So y will equal x tan 30 minus x squared g over the 2 times the 49, which gives us 98 cos squared 30. And then we know this g is 9.8, so this 9.8 will cancel with this 98. So this will go, and this will become 10. So now we have y will equal x tan 30 minus x squared over 10 cos squared 30. Okay? And then for part B, we can substitute this 0.6 in place of y to find x. So 0.6 will equal x. We can work out tan 30 as root 3 over 3 minus the x squared divided by 10 cos squared 30. We can work this out, and we get 2x squared over 15. So if I just block this off to give me more space, we'll multiply everything by 15. So we get 9 is equal to 5 root 3x minus 2x squared. We'll move this negative to the left-hand side. So 2x squared minus 5 root 3x plus 9 will equal 0. And we can solve this equation. So x will give us root 3 and root 3 over 2. Okay? Let's move on to example 2. Okay, so in example 2, we're told that a particle is projected with a speed of u from a point O on horizontal ground, and the angle of projection is theta above the horizontal. We're told that at time t seconds after the instant of projection, the horizontal displacement of the particle from O is x, and the upward vertical displacement from O is y. And we've been asked to show this equation. And then in part B, we're going to use this equation to work out theta. So again, the first thing we're going to do is to represent all of this information on a diagram. So we have our projectile motion. We have our initial velocity, which we're told is u. We know gravity is acting vertically downwards. And we're being told the angle of elevation is theta. So now we need to work out our horizontal and vertical initial velocities. So if we just have a look at this right angle triangle, when this is centered on the origin, we've got theta, we've got u. We'll call this the initial horizontal velocity, u times the cos of the angle. Our initial vertical velocity will be u sine of the angle. So now if we resolve horizontally, we know x will equal u cos theta times time. The acceleration is 0, so the half at bit will go. Resolving vertically, we know y will equal u sine theta times the time minus 1/2 of g t squared. So like we did in the previous example, we'll make t the subject of this equation. We'll substitute it into here. So t will equal x over u cos theta. So we'll substitute this into here and here. So y will equal u sine theta times x over u cos theta minus 1/2 of g times t r squared. We can see this u will cancel with this one. The sine over the cos will give us tan. So y will equal x tan theta. We can expand out this bracket, so we get x squared over cos squared theta. So we get minus x squared g over 2u squared cos squared theta. And then we know that g is 9.8. We'll divide it by the 2. So we'll get y will equal x tan theta minus 4.9 x squared over u squared cos squared theta. Okay? Okay, so we're going to use this now in part B. If I just erase all this work and move this upwards. Okay, so for part B, a stone is thrown from the top of a vertical cliff 100 meters high. So we'll show this on our diagram. We have the stone starting here. So we can show this trajectory. The initial speed of a stone is 16 meters per second. So we'll show this here at an angle projection of theta to the horizontal, and the stone hits the sea 40 meters from the foot of a cliff. So that will be our range of 40. And we know gravity is acting vertically downwards. Okay, so if we were to resolve this upwards, we know x equals 40. We know y will be negative 100. The initial velocity we're told is 16. Theta is theta. And gravity is negative 9.8. So now all we need to do is substitute these values into our equation. So y, negative 100, will equal x times the tangent of theta minus 4.9 times 40 squared over u squared 16 squared cos squared theta. We can work this out and then move the cos to the top as a sec. So we get negative 100 will equal 40 tan theta minus 30.625 sec squared theta. So the reason why I moved this cos squared to the top is because we know there's an identity relating sec and tan. So sec squared theta will equal 1 plus tan squared theta. And then I can substitute this in place of this. So then we've got a quadratic involving tan. So negative 100 will equal 40 tan theta minus 30.625 lots of 1 plus tan squared theta. So now we can expand out this bracket and we'll simplify the result. So 30.625 tan squared theta minus 40 tan theta minus 69.375 will equal 0. And we can solve this quadratic on our calculators. So tan theta will be 2.2937 and tan theta will be negative 0.9876. We'll take the arctan of both, and this will give us theta is 66.4 degrees, and theta is negative 44.6. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.